Um, this is going to go through like a sequence of, we do a lot of work with event operations with the NFL, looking at special events for collegiate and professional sports facilities. And we found that there were some things that we couldn't do with data sources that were traditionally available. And then we talked about how we use Streetlight to fill some of those gaps and potential next steps for that. So I'll start off with myself, Sumeet Kishnani. I'm a principal in transportation with Stantec's Dallas office. And we're going to talk about two different case studies. One is the NFL league-wide study that we did for several years, and then the other one is for the new Islanders Arena in the New York City area. So a little bit about that league-wide ingress and egress operation study and what we hope to do with it in the future. The task was the NFL wanted to improve the fan experience, and they said that we need to improve. We feel that the two biggest opportunity areas are game presentation and traffic and parking. And so they had a consultant for traffic and parking, Stantec, and a consultant for game presentation to evaluate those areas and identify best practices across the league and come up with specific opportunity areas for each club. So we reviewed operations at every single NFL facility for a course of 3 years, a couple of games for each club, and identified what were their biggest opportunity areas in the areas of roadway utilization, pedestrian management, signage and wayfinding, just everything that impacts the fan experience from the time they leave their house to the time that they get to their seat. We developed a toolkit of best practices that was shared across the league and a specific custom report for each club that talked about what their areas of improvement were. And this was great. There were a number of analysis areas. We categorized them in terms of how easy it was or difficult it was to implement those strategies and what the operational benefit was. So obviously you want to be up here in the top left corner, wherever possible. Oh, okay, great. So obviously improved pre-event communication, signage, and wayfinding are the easiest to implement and have the greatest potential operational benefit, especially if you have a condition like this where you have a lot of congestion and some of these vehicles we found didn't actually need to be on this road. They had other alternate routes available. And then we looked at, like I said, a holistic review of the entire guest experience. How could we improve the ingress and egress experience? Pro football facts. There's over 15 million attendees per year, so as they like to say, that's bigger than most cities if you aggregate all those people. It's a very high transit ridership, which was surprising that even facilities like Green Bay and Seattle have extremely high transit ridership. I think Seattle has one of the highest transit riderships in the across all 32 teams, which you don't really think of Seattle as a transit city necessarily, but I think they're about 20%. Relative to, let's say, New York and Chicago, but their transit utilization is much higher than some of those other cities. And even Green Bay, which, again, anyone from Green Bay here? Am I going to get objections to this? You don't think of Green Bay as a transit hub, but they run a quite extensive network of shuttle buses on game day, and people use those buses to get to different off-site parking lots, which is great for their ingress and egress operation. And the time to clear, which was one of the metrics we were evaluating, varies. When you're trying to get 60,000 people out, it doesn't happen very quickly. And we found there's a lot of variation, anywhere from 45 minutes at the really good facilities to clear that site to over 2.5 hours at some facilities, and everyone had their own impression of what was good and what was not good. So this was kind of a way to unify those MOEs and tell them how they rank relative to their peers. Some of the best practices recommendations that we came up with, pedestrian wayfinding, counterflow lanes. Pre-event communication was actually one of the simplest areas that, it's surprising how many clubs didn't have any information on their website about different travel options or travel routes, or they tell you to use Google Maps, which tells everybody to take exit 15, and then exit 15 gets backed up and all the other exits are operating well, but no one knows about them. Rideshare is another one of the opportunity areas across the league. It's very challenging, and a number of facilities just haven't accommodated rideshare very well. So they're starting to change that now with dedicated rideshare lots, pickup, drop, and drop-off areas where you have designated pedestrian and vehicle queuing, so that you don't have a queue, on the highway off-ramp as you're trying to get everybody in or out to the rideshare lot. And then other strategies like lane utilization and pedestrian management were pretty common recommendations across the league. So the deliverables were, like I said, it's an operations summary for each club, a league-wide toolkit, special event reports for things like the Super Bowl. And this was great and was well received. We made a number of improvements. The challenges we got from each club were since we were sampling, we weren't looking at every single event. So the challenge we got was that every club had a different motive, I guess, or a different outcome that they would like from the study. Some of the stadium managers were very concerned that, if I don't get a good review this year, then I'm going to be in trouble, and because that's, they didn't get a good review the year before, and they just saw their own review. They didn't see everybody else's. And some of them actually wanted to identify their worst operational areas so they could come up with actual areas for improvement. So we asked them to self-identify the areas that they wanted us to look at, and that was helpful for some facilities, and some facilities, like I said, we knew that we got the best operational areas because they wanted a good score. And then we got a lot of feedback saying that, especially for teams that didn't do so well, that it wasn't a typical game because it was a 1 p.m. start, or it was a Sunday night game, or it was a Monday game, or there was good weather, there was bad weather, it was a blowout, it wasn't a blowout. Just everything that you could use was used either as a pro or a con for why it was it was or was not a good operational event. So one of the challenges was we're sampling both geographically and temporally. We're not able to capture everything, and we're not able to go to all the games. So how do we identify this congestion? If somebody says that was one of the worst egresses that I've ever seen, how do we actually prove that? Before Streetlight, we weren't really able to do something like that. So how has it been done in the past? You have a qualitative observation of the time to clear. You can do fan surveys. You can look at agency reports, traffic counts, online traffic reports, Google Maps, and things like that. And actually, the University of A&M actually did this. They had graduate students actually counting the number of lane miles of red, green, and orange, and how long it stayed that way to quantify, the relative benefits of different operations plans. And you laugh about it, but it's a metric. And as long as you're measuring all the metrics consistently, it gives you a way to compare between different events. And you know that we made some changes, and it helped us improve the operation over here. And effectively, I think we're doing the same thing, except that we're doing it maybe a little bit more scientifically than measuring lines off of a Google Maps screenshot. So historical traffic patterns. So we wanted to look at how do the historical traffic patterns and congestion levels vary for different types of events. Was that Sunday night really the worst traffic that you've had in the last 4 years? How much out-of-town travel is there for division rivalry games? Are there differences between weeknight and weekend travel patterns? Obviously, getting out on a Monday night is easier than getting out on a Sunday at 4 p.m. Where do fans live and work? Are there different fans attending each type of event? And we found that is actually was a pretty important question, because a lot of the clubs think that they have the same mix of guests coming to each event because they sell season tickets. And when you do the surveys, and you do these kind of surveys, you find that even though it's season ticket holders buying 95% of all the tickets, that doesn't mean that it's the same season ticket holder attending each event. So at any given facility, you might only have 65% of people who are what we call frequent attendees. So if you have 65,000 people coming, you have 20,000 people that don't know what they're doing because they haven't been there before. And if you don't have signage and you don't have some kind of communication mechanism for them, then those are people that are likely to drive around and look for parking and create congestion. So another important one was who's on the roadway now, on the background, on the roadways around the stadium, and is there potential to divert this traffic? As you had talked about, where can you implement traffic diversions? What kind of signage would you need to be able to make those diversion patterns? So this is a case study we did for the New York Islanders, and we're going to share this with the league and hopefully do this for all the facilities. The Islanders are building a new arena near Belmont Park, which is one of the 3 major racetracks. They're going to have an NHL arena over there along with a retail village. And we took a look at the traffic analysis, and we said that there might be some traffic impacts when you put a stadium on top of an already congested condition in the New York City area. So we came up with a list of strategies to mitigate those impacts. It includes mode shifts, getting people to take different modes, early arrival incentives, carpooling incentives, direct communication with the fans, telling them that what to expect, kind of like managing expectations. So for example, if you tell somebody it's going to be a 30-minute wait and they get out in 15 minutes, they're happy. But if you tell them it's going to be a 5-minute wait and it takes 30 minutes, then that's not so good. Signage and wayfinding, dedicated parking and entrance areas, just kind of cleaning up the operations plan so there's less crisscrossing and more directed parking, if you will, more trying to capture people as soon as they approach the site so that they're not driving all around the site to find parking space. One of the biggest ones was background traffic diversions. We know that there's a lot of traffic on the Cross Island Parkway, which is one of the major roads next to the site, and we know that it can be diverted, but we don't know how much can be diverted. We don't know how much of that is local and how much of that is long distance. So that's where we used streetlight data. And before that, we had we're looking at other sources. We wanted to know who's using the road now. Is there potential to divert these users to other trips? How much of it is long distance versus local? Typically, we'd use Bluetooth origin destination surveys, license plate surveys. We recently, if you've done license plate surveys, I think most of the vendors that we work with that have done large-scale license plate surveys are no longer doing them for a number of reasons, because you need that accuracy, you need that reliability. It's so critical, so that if you set up a network of 20 license plate cameras and one of them goes down, then effectively you've lost all of your capture rate. Aerial surveys, questionnaire intercept surveys, and all those would be good for getting some aspect of the event operations experience, but it wouldn't really be what you need. It would be a sample. Even if you did these kind of observations, you'd get it maybe for a day or maybe 2 days. The benefits of using Streetlight for this was it's obviously less expensive. You get a larger sample size. It's not just one event. You get any event that you want within reason. You have a historical database, and then you can also use that to get other applications and get other information that you wouldn't be able to get from these other surveys. So a little bit about the background traffic diversions. This was the big one because we got a lot of comments about our strategy for background traffic diversions. It'll never happen. There's no, why would people change? So we had to really come up with a strategy to show that this was actually a viable strategy and it would make a significant impact in the travel patterns. And one thing that we always like to tell our clients is that we're not trying to get everybody to change their travel behavior. The benefit, the downside of having an event facility is you have thousands or tens of thousands of cars that are coming to the facility in a short period of time. The benefit of that is that if you get a small change in user patterns, if you get even 10% of the people to change their travel patterns, you can have a really significant impact or benefit on the overall traffic patterns. So this is the new Belmont racetrack. This is the existing site for the Islanders, the Nassau Coliseum. And adjacent to the Belmont racetrack is the Cross Island Parkway, which, like most roads in the New York City area, is very congested. And we wanted to understand who is on this road right now on a weekday evening commuter pattern which would have an NHL arena event overlaid on top of it. And why are they using this road? Is it because they're going to destinations that are local, or is it because they're using it because they've always used it as a force of habit? So we broke up the entire New York metro area into a number of very large zones. And we did a middle filter on the Cross Island Parkway just to understand who's here, where are they coming from, where are they going, and how much of that traffic could potentially be diverted to other locations. So when you look at the traffic, if all the traffic is going northbound along the Cross Island Parkway, and again, this is where the this is where the Belmont racetrack is, we found that there's very little traffic that's actually local. So for example, of all of the vehicles that are on here, 5% are going to very far east Suffolk and eastern Nassau counties, which means that they have other north-south roads that they could take. Another 22% of them are going to western Queens or places far west, again, that they can take other roads for once this road becomes more congested due to event traffic. So when you add all of that up, some of them are actually going north, but then to go in a destination to the south, so I don't know how reliable that is. But it just shows you that about 30% of the total traffic that's on this road is long-distance traffic that could potentially be diverted to other roads. And again, we're not trying to capture everybody, but when we're trying to get a 5 to 10% change in travel patterns, that can significantly improve the travel experience. So this was helpful in demonstrating that there is an appetite, there is a reasoning behind implementing these kind of travel diversions, and there are a lot of long-distance trips in the corridor. And if we divert those kind of trips, then we can have more capacity available for event traffic instead of background traffic, for example. We also, since we had this information, we took a look at fan, home, and work zones. And we did this for the Islanders play half of their games in Brooklyn at Barclays Center and half of their games in Nassau Coliseum because they originally were from Long Island, but they want to be in Brooklyn right now. And the new arena is going to be kind of a central location between the two of those. And we took a look at their fan and home and work locations. This was very useful for the club, again, in terms of targeting specific zip codes or targeting specific areas. Who's coming to our event? And we found, for example, when they were playing the Kings on a specific day, and this goes back to the question about resolution, we did these analyses for specific event days, specific time periods, so it's just not all event days at the facility. It's for a specific event day, and you can set up a separate project for each one of those event days. And we found, for example, when we were playing the Los Angeles Kings, there were a lot more people coming from Los Angeles and from California than there would be for a typical event. So it's very helpful to have that kind of information. And again, when you're looking at a different facility, looking for Nassau Coliseum, you see that kind of travel from outside. There's a couple of people coming from Texas to a hockey game in New York for some reason. But you see a lot of people coming from Florida, and it's helpful to have that homework analysis at the national level. It's also important to look at what that is for the close-up in the New York metro area. So again, there are two different facilities. There's Nassau Coliseum, which is in suburban Long Island, and there's Barclays Center, which is in more urban Brooklyn. And we wanted to see what the home zones were for people that were going to these types of events. And you'd expect to see some kind of overlap. So if you for people that are going to Nassau Coliseum, you see that they're mostly centered around Long Island, and it's a lot of local trips. It's just a historical user base for the Islanders. They're an island team. People that are in the city generally tend to be more Rangers fans, so they would be more likely to go to those types of events. But then when we looked at Barclays Center, we found something completely different. So this is Hempstead. This is where Nassau Coliseum is. And it almost seems like the two stadiums are serving entirely different markets, which was shocking at first, and the Islanders are still looking into other ways to confirm that. But when we started talking to some of the operators about this, does this make any sense? They said it's surprising for everybody who's seen this kind of analysis. Want to make sure that it actually is valid too. But what they said is when you have 40 home games, the theory is that if you're going to go to your home games, you're more likely, and you live on Long Island, you're more likely to go to the games that are close, that it's easier for you to get to, whereas people that are going to games in Brooklyn are more likely to go to games in Brooklyn. So it's a very small overlap between the two different user bases. And the other thing that was exciting for them was that they said that if this is the case, if they can substantiate this data, it shows that this is traditionally Rangers territory. This is traditionally in New York City, so there's a lot of Rangers fans in this area. And they're hopeful that since they have a venue there right now, they play half their games over there, that some of these people will continue to be Islanders fans when they move to their new facility at Belmont Park. So it's very different, and it's kind of unique in that you have several facilities that host multiple sports teams, but it's very rare to find a sports team that plays in multiple venues and be able to look at their travel patterns across those venues and see how different they are. So, other streetlight applications that we're going to be doing for them, we're going to be comparing it to travel time runs on game day, non-game day, so we can quantify what the actual benefit is. Obviously, origin destination studies, travel time studies before and during construction. This is all going to feed into the environmental document where they want us to track metrics now, before construction, during construction, and then after the new facility opens up. It helps us evaluate roadway improvement projects. So if you add a lane on one of the adjacent roads, how much did that actually help travel times for people along that route? Evaluate detour patterns, especially if there's detours that we're putting in. Have we actually been able to implement that kind of background traffic diversion? Do we need to have more aggressive signage, or do we have signage in place already? You can look at the temporal distribution of visitors to a facility. You can look at homework analyses, obviously, and we're doing this, in addition to this project for resorts and tourist destinations. We have a call later today with Lake Tahoe. We've done this for the Barrier Islands off of Sarasota, just looking at their traffic patterns and trying to understand who the visitors are, how much of it is a mix between residents and non-residents, and where are they coming from. So it's helpful for them. So for example, one of the things they found in Lake Tahoe was that it draws from a national base. It draws from people in the Northeast. There were a lot of people coming from Illinois, but there weren't a lot of people going to Lake Tahoe from Texas, and it seems surprising. And then when we talk to Texans like me and my neighbors, they said that if you're going to go to ski, you're more likely to go to Colorado than go to Lake Tahoe, and that's why there was this big empty blob in the middle of the national map for Texas, because those people are less likely to go to Lake Tahoe, whereas people from Illinois and other places are more likely to go there. So it's helpful to get those kind of results and be able to identify those kind of results. The other thing that we're working with on the NFL, so we'd like to do this again for all the teams and give everybody a report, every club a report that says, this is your average traffic. These are the areas of congestion that we've seen from not just observing a couple of games per year, but looking at all of your events. And we'd also like to combine that with real-time traffic and analytics. And we have a Google Maps API platform. Again, so how has it been done in the past? You do video observations, you get somebody out there in the field and they're looking at their corridor and looking at queue lengths over there, but they don't get the big picture. What's the frequency of updates? Do the traffic patterns match the actual traffic data patterns? You know, if you're looking at some kind of an analytics source like let's say SIG Alert or INRIX, does it actually match? INRIX is notoriously biased because it's very heavily weighted towards commercial fleets. So if you have a corridor that doesn't have a lot of commercial fleets, then you might not get very good data on there. And is it sensitive enough to differentiate between, for example, a managed lane and a frontage road? We do a lot of work with toll roads all around the country, and a lot of our toll road clients want to know what's the time savings advantage on the managed lane and the frontage road? How much does it cost, and how hard is it to implement the data collection program? And is it? And everybody asks this question: is a deliverable proprietary, or is it something that you can easily access and share? So since Streetlight does not currently have a real-time platform, we're combining this with Google Maps API data, and we tested this at several locations, and it's kind of like went through a philosophical experience over here. Google Maps reports free flow and typical speeds, and also actual real-time speeds. And the question was, is it updated? Is it accurate? How useful is it? And can we actually develop any kind of metrics based on that? Does it have that level of robustness? And what we found is we looked at a corridor in Austin where we had Wavetronic sensors set up on several different lanes. So every lane was recording the occupancy, the speed, the number of vehicles, and we compared that to information from Google Maps, and we found that it was actually pretty accurate. It was updated every 4 or 5 minutes. So we have this essentially this tool, if you can define the routes strategically, that you can use to essentially recreate real-time traffic information. But the other thing that was very important that the client liked to see is that all those dots represent different lanes. So what we found is, when you do an observation, it's an approximation of reality, right? So this was a scenario where you could have 4 different lanes at that same 4-minute window that they're reporting the speeds. They could be off by as much as 15 miles per hour. So this goes back to like a philosophical question of what is reality? Is it really 35 miles per hour? Is it 50 miles per hour? It's different depending on the quality of the sensor and the quality of the data. And using the available information from Google kind of gives you an average of all of that information. So what we want to do in the future, and then this is like another typical day where we looked at we wanted to say, Google thinks it's going to take 45 minutes. Does it actually take 45 minutes, or is it able to account for real-time congestion? So this was a day when we had some kind of congestion, more congestion than usual, and you can see the fluctuation over the course of that. It's very precise. It goes down in every few minutes, in every 4 minutes or so. So it's a good real-time tool to supplement the stuff that we're doing with Streetlight. And what we're doing now is actually we're building a database of all of these actual speeds for several corridors, for several metro areas across the country. And once we have that information available from Streetlight, we'd like to be able to develop that comparison and see how well the two sources match up in a few months from now. And that's, I think, the next step is we want to have this database. We want to be able to tell people, not be limited by having people out there in the field to do observations, but actually get the big picture view, be able to look at all their facilities and all the event days. We want to identify discrepancies between event days and non-event days. That's something that everybody wants to know about. How much worse is it on an event day? Because when you're dealing with a municipality, they want to blame everything on the event sometimes. We want to identify trends between traffic congestion, start time, weather, opponent, attendance, day of week, all those things, all those excuses that we got from, the weather was good, traffic was bad, the weather was bad, traffic was bad. It was a Sunday night game, it was a Sunday afternoon game. So we want to be able to actually, quantify this and apply some science to it and be able to say, is there any correlation between that, or is it just, is it just the opponent? Create a congestion index so that, a team can get, right now, they really don't have a way of knowing just how bad it was relative to all the other days. So this will help put everything in perspective. We observed the Seahawks event 2 days ago. And they actually, we said we don't have any problems during egress because it was a very good egress. It was very well managed. They knew we were there, so maybe they were doing things differently. But they actually said that's one of the best egresses they've seen in the past 4 years. And for us, having observed one event, we can't quantify that. But having this kind of information will help us to actually put that in perspective and say, yes, it actually was one of the best ones that you've had. Next steps. Neil's in the room. So when you're doing something like this for an event facility, it's great to have that kind of resolution and to be able to pick out specific days and specific times. What would be helpful is if there was some kind of an API, and I know I spoke with Ted and he said there is an API, but it doesn't let you pick specific days, for example. So ideally what we'd like to do is to be able to upload a CSV file of their 41 home event days and just be able to get a separate project, set up a separate project for every one of those event days so we can download that data in CSV format and do all the comparisons that we'd like to do. And especially if we're going to be doing this for the league for 32 teams for 4 years and 10 home games per club, it can get a little bit cumbersome going in there and setting up individual projects for every one of those. And then another one is something that my colleague asked me to mention is the idea of the point cloud. When you work with INRIX or some of the other providers, you get the point cloud. And I think part of the reason you get the point cloud is because it's a very small sample. INRIX has a small sample. The other providers have they don't have the location resolution that we have with Streetlight. But one of the questions that I asked one of our travel demand modelers, I do mostly simulation modeling, but I asked our travel demand modelers is, can we get a path file of every trip in the network? And if you look for a large metro area, they said, first of all, they looked at me like, what are you talking about? So what I said is, can we get every origin destination and the path for every link that they followed along there and the time that they started on each one of those links? And the answer I got was, yeah, they got a little upset about that. But they said, yeah, we could probably do that, but it'd be like a 400 gigabyte file. What are you going to do with it? And I managed to convince them to give me that file so we can actually try to process that. But the question is that something that can be done with the Streetlight platform as well, where you get the origin zone, you get the destination zone, so you don't go down to the individual dots, not every single ping, but you're able to identify the origin zone, the destination zone, and every link that they took and the time that they crossed all those links for each trip, so we can do our own kind of geospatial analyses if we need to. So, for example, identifying residents and non-residents and visitors, non-visitors, and things like that. That's it.
Cool. Thank you.